Good morning. My name is Malambo Monga. I'm from Zambia, the country covered in a lot of fire events. There's been a lot of work that has been done on fire on a coarse scale using MODIS, but my work has concentrated on understanding the fine-scale seasonal fire events in Zambia. So today I just want to highlight some of the methods we've developed to facilitate the temporal mapping of seasonal fire. So some of the challenges that we've faced is the issue of missing data. I know many people have highlighted this already, but I'd like to just stress that for seasonal mapping, you have a different set of challenges because you don't have the luxury of all the scenes in the image. So you have to move towards something that will be able to preserve the changes in the imagery that you want to use. So we've tried to move towards a change-preserving missing value imputation methodology. And then the second one is to be able to collect the data, the training data automatically to facilitate faster implementation of the mapping. Yeah, so the opportunities that come with multitemporal analysis is just that there's a temporal profile that can be leveraged for both missing value imputation using the similarities in the profiles, and also their distinctive characteristics to be able to automatically define your training data and facilitate quicker generation of information. So the problem here is that we want to track burning over the season and want it to be consistent with time. If you did mosaicing or temporal composting, you wouldn't be able to move very well because some pixels, temporal profiles only have maybe one value, maybe in the list of 10 images. So we've been able to do this to be able to track fire over the season. So we've used an index called the mid-infrared bitemporal index. And the green parts are the lower, and then red is what would be indicative of fire. But as you can see, it also responds to the river. But as you can see, the river wouldn't be picked if wouldn't be a change because it's the same throughout. So that was an illustration. So the performance also in over large gaps is that our developed methodology can actually facilitate creation of such information over large gaps and be able to get something that is spatially consistent and also temporally consistent. So for the training data collection is that we have used the distinctive nature of the temporal profiles to be able to come up with a training set. So we have, like on the top, the one which corresponds to unbent, up to the one which corresponds with something that bent before the last image. So we've been able to do this to generate something like that. So you have fire beginning in June, and then it progresses until the month of October. Most of this has been done using the Google Earth Engine user interface, the graphical user interface. But our wish is to move to the API so that this can be actually implemented over a larger area in Zambia, because as you see, fire is happening everywhere. I think I'll end here for any questions.